Hi everybody. I want to work out one of the problems in your homework very thoroughly, just in case anybody needs a little extra help with logarithms. So here is the problem. It's page 268. Let me move this out of my way and let me write this down over here. It's page 268 in your book. It is section 6-8, and it's problem number 24. And here is the problem. It is 18 times 5 raised to the negative, let's put a 0 in front here, 3/10 x is equal to 7 thousandths. Now this is where I want to use logarithms. When I have a variable in the exponent, that's really the only time I want to use logarithms. Other than that, I can just solve it using regular algebra. I don't need the logarithms. But in this case, I have to find x. And so the easiest way to do this is, first of all, to divide both sides of this equation by 18. The reason I am doing that is just so that I get this 5 raised to the negative 3/10 x by itself. See, I'm trying to get the x by itself, right? I'm trying to solve for x. So to do that, I want to get rid of the 18 in front there and divide both sides by 18. Okay, so the 18s cancel here, and I can see that I just have 5 raised to the 3/10 x is equal to, and I'm not going to work this out, it's equal to 7 thousandths divided by 18. I could, that's just a number, but I just don't want to round, so I think I'll just go ahead and leave it there. All right, now this is where I have to use logarithms. I'm going to take the log of both sides. All right, so I don't know, just pick another pretty color here because it's fun. All right, so I'll take the log of the left side. I'm going to get negative 3/10 x. Okay, is equal to the log of the right side, which is 7 thousandths divided by 18. Okay, whatever that number is, it just represents a number, right? And I have the log of this. Now remember, when I have an exponent in the argument of a logarithm, I can take that exponent out and multiply. This is my law of logarithms, right? One of my properties of logarithms. I can take that exponent out and multiply it by the log of the rest of the argument, which is just 5 here, the log of 5. Because remember, the log of 3 to the 5th does equal 5 times the log of 3. Do you remember that? That's one of the properties of logarithms. All right, so this is just an exponent. I'm just going to take this exponent right here, okay, and I'm moving it in front of my log function there. All right, so I don't want that right now though. Okay, this is going to equal here, and I haven't done anything with the right side. It's still just the log of 7 thousandths divided by 18. Okay, now the log of 5 is just a number, so I'm going to do kind of the same thing I did before. Let me pick another color just to keep emphasizing what I'm doing here, or keeping it all straight. I'm going to divide both sides here by the log of 5. Divide both sides by the log of 5. And I get, and I'll just again pick another color. I get negative, okay, 3/10 x is going to equal, and now I know this looks complicated, but it's really not. It's going to equal the log of 7 thousandths divided by 18, okay, divided by all of that divided by the log of 5. And all of that, it's just a number. Those are just numbers in there. So here I go. I'm going to do this on my TI-84. Now remember where the log function is on the TI-84. It's just below the x squared, just below it, and it's right to the left of the number 7. All right, so I'm just going to type in log of 7 thousandths divided by 18, and then I'm going to press the divide key, divided by, and then I press log 5. And I wish I could show you that on a TI-84, but I can't bring one into the classroom yet. I don't have that software, but hopefully I will soon. And this is what I get. Let me put all this right here. Let's just squish this down a little bit here, and I think I'll get rid of, let me erase all that just to get it out of the way and looking a little neater here. Okay, now, so when I did all of this, all I did, I pressed the log button of 7 thousandths divided by 18, and then I divided that by the log of 5, and I got -4 and approximately. Let's round this to the nearest thousandths place. So -4 and 879 thousandths is equal to -3/10 x. And maybe technically we really should put approximately here. And now I'm going to divide both sides here by -3/10. This side and this side by -3/10. Okay, and I could see here that I get x is approximately then -4 and 879 thousandths, and I'm dividing that by -3/10, and I get 16 and 263 thousandths. Now I could always check my answer. Go check it. All I have to do is put that in for x and see if it works. Check your answer. Does 18, okay, times 5 raised to the -3/10 times 16 and 263 thousandths, okay, does it equal 7 thousandths? That's the question. Are these equal? And the answer is yes. If you take on your calculator again, you're just going to take 18 times 5, and you're going to raise it to, and put all this in parentheses, -3/10 times 16 and 263 thousandths. And I get, what I'm getting here on the left side, I'm getting 0.06999 5 ... It just keeps going. And is that equal to 700ths? Well, definitely close enough, right? It rounds to that. And so we're going to say yes, that is a check. All right, so hopefully that helps you out and helps you understand logarithms just a little bit better. I probably didn't have time for this much detail in class, and so I'm hoping going into this much detail here will help some of you out. All right, have a great rest of the day. Talk to you later. Bye-bye.